Today we're starting 3-4, find and use slopes of lines. Like I said, the rest of chapter 3 should be a review from Algebra 1. It's good news. All right, evaluate A minus B over C minus D if A equals 5, B equals 2, C equals 1, D equals 7. So we just got to plug all this stuff in. In my numerator, I would end up with 5 minus 2, my denominator, 1 minus 7, 3 over negative 6, and that would reduce to negative 1/2. What about the reciprocal of 2/3?
3 over 2.
3 over 2, or 3/2. Questions, concerns on the warm-ups? Okay, we'll move on. Slope is a ratio of vertical change, which would be called the rise most of the time, to the horizontal change. Which we refer to as the run between any 2 points on a line. Okay, so we refer to slope as the letter M, hoping we remember that from algebra. We often call it rise over run. You might see it as change in Y over change in X. When we're dealing with coordinate geometry or algebra, one of the most useful ways that we find slope is to take y2 minus y1 over x2 minus x1. I will make a note here that this would be the same as taking y1 minus y2 divided by x1 minus x2. So I don't care if you want to put your sub 1 first or your sub 2 first. You just have to be consistent. Meaning it doesn't matter if you start with the second coordinate or you start with the first coordinate. You just have to be consistent when you do that from the numerator to the denominator. All right, it's not my favorite jingle, but somebody in the math department likes it apparently. Slope is easy, slope is fun, slope is always rise over run. Who did? Oh, nice. All right, label whether each line in the diagram has a positive, negative, 0, or undefined slope. Line A, what do we think? 0. Any horizontal line will have a 0 slope. What about B? Undefined. Vertical lines have undefined slope. C is a negative slope. If it goes downhill from left to right, it's negative. And line D, positive. If it rises from left to right, it's a positive slope. All right, on example 1, we are asked to find the slope of line A. Now, if you really want to, you could identify those coordinates, and you could use the formula, y minus y over x minus x. But if they give it to you in a graph, it's much easier to just count. So I would start at the point that's closer to the left side, and we're going to count our rise and our run. How many do we rise? We rise 4 over we run 4, and that reduces to 1. If you write it as 1 over 1, that's fine. We should be labeling it as M, so we know we're talking about slope. Questions, concerns? Getting those warm, fuzzy, nostalgic feelings for Algebra 1. Okay. Next one, find the slope of line B if it goes through the points 4, 6, and 7, 3. Now again, we could graph this line, put the points on there, draw a line through it, then count our rise over run. But if they don't give us a graph, it's easier to use the formula. I will write it up here just as a refresher. Again, I don't really care if you start with your y2 or your y1, as long as you are consistent. So which y coordinate do you want to plug in first? 6. Okay. So again, it doesn't matter to me. But if we start with 6 on the top, what do we have to start with on the bottom? 4. That's what I mean about being consistent. Okay, so in my numerator, I would have 6 minus 3. My denominator, 4 minus 7. 6 minus 3 is 3. 4 minus 7. And when we simplify it, we get -1. So our slope is -1. If you put -1 over 1, that's fine with me too. Questions, concerns? I know we went through it quickly, however, it is a review. Okay, we'll keep it moving. Slopes of parallel lines in a coordinate plane. 2 non-vertical lines are parallel if and only if they have the same slope. Parallel lines must have the exact same slope. Any 2 vertical lines are parallel. Okay, any 2 vertical lines are going to be parallel. They would both have an undefined slope. Slopes of perpendicular lines in a coordinate plane. 2 non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals. So opposite means what happens to it? What do you mean flipped? They will intersect, but in math, especially in, very good. Opposites mean one's positive and one's negative. So the word opposite means one would be positive, the other would be negative. Reciprocal would mean that if it's a fraction or if we write it as a fraction, we flip it over. Okay, so both of those things have to happen. Change the sign, flip the fraction. If it's not written as a fraction, you have to write it as a fraction. We might see some examples of that soon. Lines whose slope have the greatest absolute value are steepest. Okay, so what that means is that a line with a slope of +6 and a line with a slope of -6, they would have the same steepness. They would just be sloped in opposite directions or different directions, one going up, one going down. So lines whose slope have the greatest absolute value are steepest. Anybody need more time here or have questions on this slide? Okay, we'll keep it moving. Find the slope of each line. Which lines are parallel? Okay, you have a coordinate plane there, so if you would rather plot your points and draw your lines, that's fine. If you would rather use your slope formula to find the slopes and not use the graph, that's fine. I'll give you a couple minutes to work through it. I'm going to be plotting points on the graph so I can see my lines. I would also recommend if you're using the coordinate plane, is go ahead and put a line through 2 points right after you make them. I would not plot all 6 of those points and then try to figure out which ones are supposed to be connected. All right, lines 1, 2, and 3. What did we get as our slope for line 1?
I got 5. I got 4.
Okay, so I went ahead and plotted these points, so let's just count them.
1, 2, 3, 4, 5.
Okay, up 5, and then our run is over 1. So I would agree with 5 over 1 or 5 as our slope. 5 over 1 or just 5. If you did it using the formula, your y's would have had to have been -1 minus -6 over -3 minus -4. When we subtract a negative, what are we really doing? Adding. So again, we would have gotten +5 over +1. All right, what did we get for our slope on number 2? 6 over 1. Are we all in agreement there? Okay. Slope is 6 over 1 or just 6. And what about our slope for line 3? 5 or 5 over 1 again? Okay, which lines are parallel? 1 and 3. So we could say line 1 parallel to line 3. They had the same exact slope. Which one is the steepest? Line 2. Good. Taylor?
For the first one, I did the formula, but I got 5 over -1.
Did you plug them in like we did, or did you do it swapped?
The other way.
Okay, so let's look at the other way real quick. So you started with -6?
No, I did -1 minus -6 over -1 minus -3.
Okay, so that's where the issue comes in. If you start with -1, you have to start the bottom with its friend -3. That's what I meant about being consistent. So if you're going to start with -1 minus -6, then below it better be their pairs. So -1's pair was -3 minus a -4. Another way, if you happen to have the graph and the number at the same time, we should be able to see from the graph that line 1's slope is definitely positive. It's going uphill from left to right. So that's another way we can double check ourselves. Other questions? That's a good one. Common error that can come up. Okay, we'll keep it moving. Tell whether the lines through the given points are parallel, perpendicular, or neither. Now on these they did not give us a graph, and I'm not going to take the time to make a graph, so we will just use our slope formula. So for line 1, I'll make my line 1 red. In the top, we've got to take a y coordinate minus the other y coordinate. So what do you want to do? Okay. 5 minus 3 works. Y minus y. And then in the denominator, we have to take x minus x. Now this time they happen to be the same. So we're taking what minus what? -1 minus -1, which I agree is the same as -1 plus 1. If you go ahead and change this to a plus sign right away, that's fine with me. 5 minus 3 gives me 2. -1 plus 1 is 0. What does that mean for my slope? It's undefined. So slope is undefined. If you put U and D, that's fine. All right, line 2, I'll make blue. For line 2, in my numerator, y minus y. What do you want to do? Okay, 6 minus 0 over 0 minus 0. That would give us 6 over 0, so my slope is undefined again. So we were asked, are these lines parallel, perpendicular, or neither? I think I agree with John. If their slopes are undefined, they are going to be vertical lines straight up and down. And that means that they are going to be parallel. Okay, if both of them have undefined slopes, then they are both vertical lines straight up and down. They would be parallel. Questions about example 4? Okay? Same kind of thing for this next one. So I'll give you a couple minutes to work out your slopes and compare them. We'll talk about it in a minute. Even if you set it up differently,
Use the X and a Y.
ooh, good call. I agree. You got an issue. All right. What is the issue?
Use one X and one.
Good. We got to be consistent. So in the top, we should have had 2 minus 3. And in the bottom, we would have had -5 minus a -2 or +2. So we just got to flip those. Okay, so let's correct that. 2 minus 3 gives us -1, -5 plus 2. Okay, and then we should simplify that to become what? A positive 1/3. All right, we feel better about that? Okay, good. Again, we just gotta be careful with our x's and our y's. If you want to like put x's and y's over them before you get started so you can keep track of them, that's something that works for some people. Some people like to use like arrows or little connectors. You could do that as well. It doesn't matter to me. Something so we keep our x's on the bottom, our y's on the top. All right, somebody want to tell me how they set up to find their slope for line 2? Akira?
I put 3 minus 1 on
3 minus 1 on
top.
top.
And then 5 minus 4 on the bottom.
5 minus 4 on the bottom. Are we in agreement here? Okay, good. 3 minus 1 is 2 over 1. You could leave it as 2 over 1, or you could just write it as 2. So then comes the question, parallel, perpendicular, or neither? One person thinks they know. Neither. Okay, I think I heard 2 or 3 voices that time.
How do you know when it's perpendicular?
If they're perpendicular, they are going to have opposite reciprocal slopes. So what is the opposite reciprocal of 1/3? -3 over 1. So if that had been -3 or -3 over 1, then those would be perpendicular. Or what's the opposite reciprocal of 2? -1/2, and then those would have been perpendicular. But since neither of those situations occurred and they were not the same exact slope, it's neither. They will intersect each other, but it won't be anything special. Other questions on example 5? Okay, is this still feeling like a review? For the most part, at least. All right, graph a line through 0, 3, and parallel to a line through -2, 4, and -5, 1. So I would go ahead and graph that second line first. If we're going to, well, we don't have to. let's not graph the second line. Let's just go ahead and find the slope of the second line. If you did graph the second line through the -2,4 and the -5,1, that's fine. But I don't want to end up getting confused when we go to graph our answer. To find the slope through those 2 points at the end, what's going in my numerator? If it helps, I can write the point there. We got at least 10 minutes.
4 minus 1.
4 minus 1 would work. Take a y minus a y. 4 minus 1. And then in my denominator, I would have, okay, -2 minus -5, or you can just write -2 plus 5. 4 minus 1 is 3. -2 plus 5 is also 3, so our slope is 1. If you want to write it as 1 over 1, that's fine. So if we want our line to be parallel to that line, we want our new slope to also be what? 1. We want to use the same slope if we want our line to be parallel. Same exact slope. So if that slope was 1 over 1, our slope will be 1 over 1. I'll go ahead and graph the first point that they gave us at 0, 3. Where's that going to be?
I don't know why.
On the y-axis, up 3. Okay, and if we want to use a slope of 1 over 1, I can make more points on this line by using that as rise over run. So from my point here, where am I going to go? Up 1 and over which way?
Right.
To the right. So up and to the right, up and to the right, up and to the right. We can make lots of points. Good. If I didn't want to keep going up and right or I ran out of room, I could also reverse it and go down and to the left. A negative over a negative is still a positive. So I can go down and left. You don't need to get all the points that it's going to go through, but the more points that you have, the better your line would be. When you do this, I do expect that your lines are going to go through the whole coordinate plane so that I can see it clearly. You should be using a straight edge to make these. Now, if you have such a steady hand that I can't tell the difference, that's fine. But I can tell you right now, if I were freehanding this, like my line is not super straight. I don't want squiggly lines. I want straight lines. Now, on the iPad, I do have a straight line maker that helps me do that. Are we all clear on what my expectation is for your lines? Okay, use your ID or something else. Your coordinate planes aren't that big. Straight lines. Questions on number 6? Okay. Number 7, we are going to graph a line through 1, 4 and perpendicular to a line through -2, -2, and 3, 0. I, again, want to start off by finding my slope that I want to use. To find the slope I want to use, I first have to look at the slope of the line that they're giving me. So to find the slope of the line through those 2 points on the end, what's going in my numerator? Okay, we could do 0 minus -2 or 0 plus 2 over what? 3 plus 2. If you want to do it the other way, where you take -2 minus 0 and -2 minus 3, that's fine. You should get the same slope in the end. What is our slope? 2 over 5. But if we want to be perpendicular to that, we don't want to use that slope. What slope do we want to use? Good. Opposite reciprocal. So we want to change it to be -5 over 2 when we use it. Questions about just that part of the process? Okay, then we graph our starting point from the origin. How do I get to the point 1, 4? Right one, and then up 4. That's the point 1, 4. If I am using the slope -5/2, where do I go from there? Down 5 and right 2. Down 5, right 2. Could probably do that again. Down 5, right 2. If I had room, instead of going down and to the right, where else could I go? Up and to the left would be my other option. That's not going to fit on this one, so I'm good with what we've got. And we can graph the line through those points. Now, if we were to go ahead and graph the other line, we should see that these would end up being perpendicular to each other. They might not cross each other at a nice intersection point, but if I get a good angle on that, we should be able to see that these lines are perpendicular, meaning they meet at a right angle. Okay. Questions about our lines? Slopes. Okay. Find the unknown coordinate, so the line through the points -3, 2 and 0, y has a slope of -2. Well, we start setting it up like we would finding slope. In my numerator, what would I put? My numerator's got to be the y coordinate minus another y coordinate. So we could put y minus 2. You could put 2 minus y, but I'd rather have a positive y personally. If in the top we put y minus 2, my denominator should be 0 minus -3 or 0 plus 3. And what should I be setting that equal to? -2. That's what they want my slope to be. We can simplify this a little bit because in my denominator 0 plus 3 is just 3. How am I going to start solving for y? No. Multiply both sides by 3. We got to get rid of that big fraction bar first. So the 3's would cancel out on the left. We're left with y minus 2 equals. Now what would we do? Add 2 on both sides. We get y equals -4. Questions about example 8? All right, we do have homework. It should be on your assignment sheet. It is out of the textbook.